Hello everyone. Today we are going to discuss about the memory management unit. In this we are going to discuss about the page replacement algorithms. So let's get started. Basically there are three algorithms for page replacement. So first one is first in first out, second one LRU, which is least recently used, and third one is optimal algorithm. So here we are going to discuss the first LRU algorithm, that is least recently used. For this let us consider process P1 with page reference string given as below, and here if you see there are 10 pages required for the execution of this particular process P1. Reference for these pages is as given in the reference string. Also page frame size is given as 3. So out of these 10 pages only 3 pages can be loaded in the main memory. How to load these pages now, and how to replace them, and how to go for the total execution of the process, that we are going to see. Now this we need because we want to go for the multi-programming or multi-processing. So multiple processes must be present in the main memory. So here we can see every time one of the page will be loaded from the secondary storage device into the main memory. Now CPU is going to ask for the different pages as per the sequence given. Now right now if you see this particular table, none of the page has been loaded in the main memory. It is empty. Now CPU is first requesting for page number 1. Now as page number 1 is not there in the main memory, so it will be loaded from secondary storage to main memory first. So page number 1 is loaded in the memory. As it is the new page that has been loaded in the memory, there is a page fault. Whenever any new page is loaded from secondary storage device into the main memory, it is called as page fault. So this is the first page that has occurred. Now CPU is demanding for page number 2. Now page number 2 is not there in the memory, so it should be loaded from the secondary storage again into the main memory. So page number 1 will remain as it is, and now page number 2 will be loaded. Again, as it is a new page that has been added here, there is a page fault. Now next page, CPU is demanding for page number 3. Now page number 3 is also not there in the main memory, so it has to be loaded from the again secondary storage into this main memory for the execution. So page number 3 will be also added here. Now as again page number 3 is again a new page, that's why there is a page fault. Now CPU is demanding for page number 4. Now if you see, page table is full or page frame is full, so that's why this page cannot be loaded directly, as we have loaded page number 1, 2 and then 3. So what we'll have to do, we'll have to replace one of the page from 1, 2 and then 3. Now which page will be replaced? So this will be decided by the algorithm. Now here we are going to replace it by least recently used algorithm. For that, first we'll see what is least recently used. So if you see here, current page that has to be loaded is page number 4, and before page number 4 we have used page number 3. So page number 3 is most recently used page. Before that we have used page number 2, and before that we have used page number 1. So out of this 1, 2 and 3, page number 1 is least recently used. As page number 1 is least recently used, page number 1 will be replaced by page number 4. So now page number 4 is loaded into the memory at the place of page number 1. Again, as page number 4 is new page, that is a page fault. Now CPU is demanding for page number 2. Now if we see, page number 2 is already there in the memory, So as it is already there, no need to load it from the secondary storage into the main memory. So whenever any page is already present in the memory, that is called as page hit. So this is given by the green color, and then it is denoted by H. Page fault we are denoting by red color and F, and page hit we are denoting by green color and H. Now next, CPU is demanding for page number 1. Now page number 1 is not there in the page table, so it must be loaded from the secondary storage. Now first we'll see again which is the least recently used page. So page number 3 is the least recently used page. Now if you see for this one, 2 is the most recently used. Before that we have used 4, and before that we have used 3. So 3 is the least recently used page. So 3 must be replaced by 1. So 3 will be removed from the main memory, and it will again go in the secondary storage, and from secondary storage we are going to take page number 1, and then it will be loaded in the main memory. Again, as this page number 1 is new page, that is a page fault. Now CPU is demanding for page number 4. Now if you see, page number 4 is already there in the memory. As it is already there, no need to load it from the secondary storage. Again, there is a page hit. So in this case, there is a page hit. Next page, CPU is demanding for page number 5. So page number 5 is not there in the main memory. So we will have to load it from the secondary storage. So where it will be loaded? Now for this 5, page number 4 is most recently used. Before that we have used 1, and before that we have used 2. So 2 is the least recently used page. As 2 is the least recently used page, it will be replaced, and then new page 5 will be loaded in that location. Again, as there is a page number 5 is a new page, there is a page fault. Similarly for page number 6, CPU is demanding for page number 6. It is not there in the memory, so it will be loaded from the secondary storage device. Now out of this 4, 5 and 1, 1 is the least recently used page. As 1 is the least recently used page, it will be replaced by 6. Now page number 6 is loaded in the memory, and there is a page fault. And the last page is page number 1. Now page number 1 is not there in the memory, so we will have to load it from the secondary storage. So for this, out of this 4, 5, 6 which are present in the main memory, page number 4 is the least recently used page. As it is least recently used page, it will be replaced by 1. Likewise, all the pages will be replaced, and execution of the process will be completed. Now here if you see, total number of pages are 10, total number of page faults are 8, and total number of page hits are 2. So from this we can find out the hit ratio. Hit ratio can be calculated by the formula, that is number of page hits divided by total number of pages. In this case, number of page hits are 2. So 2 divided by 10 into 100 will give you the hit ratio. In this case, it is 20%. So likewise, we can calculate the hit ratio for different algorithms, and then we can compare it. Thank you.